Today I'm going to talk about how to graph trigonometric functions, in particular, the sine and cosine function. I presume that most students would know how to graph the basic sine and cosine function, but if these functions have, for example, dilation, reflection, and translation, then some of the students may be quote-unquote lost in transformation. Here I will present the step-by-step procedure for graphing this function. The first step is to find the maximum and minimum of the function. Since the basic sine function has a maximum value of 1 and a minimum value of -1, this particular function has a maximum value of 3 and a minimum value of -1. The second procedure is to find the period of the function. In this case, k equals this number, and the period equals to pi. The third procedure is to find the xy coordinate of the starting point. The fourth procedure is to find out whether the graph goes up or down after the starting point. Here we see that the graph is equivalent to y equals to -2 sine theta plus 1, where theta is equal to 2x plus pi on 3. As theta increases from the starting point in the anticlockwise direction, the magnitude of sine theta increases. As a result, the value of y increases in the negative y direction. Next, we shall fill out a table for the maximum and minimum position of the graph. Before we do that, I would like to point out that vertical translation will destroy the x-intercepts, whereas the horizontal position of the maximum and minimum will remain the same. The effect of a vertical translation of the sine or cosine graph on the horizontal positions of the maximum, minimum, and the x-intercepts can be seen on this graph. Here the blue graph is a vertical translation of the red graph. We could see here that the maximum and minimum positions are unchanged, whereas the x-intercepts are destroyed by the vertical translation. Next, we shall fill out the maximum and minimum table for the graph. As x starts from -pi, the angle theta rotates in an anticlockwise direction. The first maximum or minimum for theta occurs at theta equals to -3 pi on 2. As a result, x is calculated to be -11 pi on 12. And since this is a negative sine graph, this corresponds to a minimum. Notice that the minimum and maximum are separated by a period of pi on 2, so we could easily fill out the rest of the maximum and minimum table. Each maximum and minimum are separated by a period of 6 pi on 12. Notice that we stop the table at the maximum of 7 pi on 12 because adding another 6 pi on 12 to this number would exceed the maximum domain, which is pi. Next, we shall find the x and y intercept of the function. We find the x-intercept by solving the equation y of x equal to 0. And we find the y-intercept by substituting x equal to 0. Here I shall skip the process of solving for the x-intercept and may be leaving this as another subject for another video. The next thing to do is to mark the start, end, maximum, minimum, and the xy intercept points on the paper. Thank you for watching. Please visit my website www.samtotutoring.com.au for more videos and downloads. Thank you.